Hey everybody, welcome back to another edition in geometry. It's Mr. A here, fresh back from Jamaica for another edition of Geometry 7.1 is what we're going to be talking about today, ratios and proportions. So let's get started. Our objectives today, we're going to learn to write ratios and then write and solve proportions. Now, a lot of this you may have seen in Algebra 1 as well, but we'll take a look at all this. All right, first of all, a ratio is a comparison of two quantities using division. And so here's a little example that we'll do, but and we'll kind of talk about the ratio as we go along here. So it says the width of a TV screen is 32 inches, the height is 18 inches. What's the ratio of width to height? Now, first of all, there's several ways that you can set up the ratio. It's you're comparing two quantities using division. So, you could say, okay, well, here's my two quantities. What order do I put them in? Well, notice here it says what's the ratio of width to height. One way that you could write this is you could say, I'm going to start with this one. 32, since the width was written first, 32 would be on top. 32 divided by 18. That's one way that you could write a ratio. We're going to get back to this in a little bit more to finish that out. But other ways that you could write this ratio as well, you could say, well, I could say 32, and just write 18, 32 to 18. I could use that. If you write it that way, the 32 comes first. So if it comes first, width comes first, it goes on top. If you write it this way, it goes first. Another way you could write this would be 32 and then two dots, 32 to 18. That would be another way that you could talk about that ratio. Now, however, there was one problem with this. Whenever we've got a ratio, we want to simplify this down as much as we can. And so you notice this is just like a fraction. So really we're just simplifying a fraction is all we're kind of doing here. So look at 32 and 18. What can you do? You could divide both of those by 2, right? So if we divide this by 2, this will be 16 over 9, or 16 to 9. Can we reduce that anymore? No, that's it. 16 will divide by 2 or 4. Won't divide by 3. 9 will divide by 3, but that's it. So this is going to be our ratio here, once we've got it all simplified, is 16 to 9. Or here, if we simplified this, it would be what? 16 to 9 instead of this, and 16. Ooh, I'll try to make that a 9. There we go. So 16 to 9, 16 to 9, or 16 to 9. One just quick highlight here, or sidebar. So this is the proportion width to height in a TV. This is like an HD TV, and I don't know, this might be all you've ever seen, but these HD TVs they're a little bit wider like this. It'd be like 16 units by 9. In the old days, this is HD. In the old days, the standard was what? It was, if you've ever seen one, it's more square like this. It was 4 by 3. And so this was the standard, or the non-HD. So these days we've got wider screens. Just a little side note. All right, no extra charge for that extra bit of information. No extra charge today. Okay, secondly, I don't know what just happened to my screen there. And we're going to try it again. Secondly, is a unit ratio. Okay, a unit ratio is when we take a ratio and we just make the denominator 1. Okay, so remember in the last example we had 16 to 9. That is not a unit ratio because 9 was in the denominator. So if you do a unit ratio, the key thing is that you want to get to 1 and the bottom of the fraction, which means you might get a decimal or something like that up on top. Okay, so let's take a look at how that might work here. So another thing that I really like, I used to work in TV, and I also coached baseball and played baseball. So baseball example today. In 2006, Joe Mauer had the highest batting average in Major League Baseball. Here's what he had. He had 521 at-bats, and 181 hits. Find his batting average. Well, his batting average is how many hits per official at bats. Okay, so it doesn't count walks or things like that. And so this is really just a proportion. So we're going to say, well, it's a proportion of hits to at bats. Okay, and so it's going to be 181 hits to 521 at bats. Okay, so now what we want to do in the batting average is just taking this ratio and getting it down to a unit ratio where the denominator is 1. Well, how would I do that? Really, all I'm going to do is I'm just going to divide this on the calculator. So on my calculator, I'm just going to do 181 divided by 521. And what I get is, I get a decimal here. I'm going to round it a little bit, but that's approximately 0.347. And then there's some other stuff, but in baseball batting average, they usually use 3 decimal places there. So this really, when you divide this out, what you're doing is you're just saying this is 0.347 to 1 for 1 at bat. So, so for every 1 at bat he gets, 34.7% of the time he gets a hit. So that's what batting average is, and in this case, that's a good example of the unit ratio. Okay. All right. By the way, 340. If you hit over 300, that's considered really good. All right. Extended ratios. Okay, an extended ratio is you're going to compare 3 or more quantities. Okay, and that means they're all in relationship to each other. So, for example, here's little thing that I put down. A, now I'm using the 2 dots this time to show this, but A to B to C. This is an extended ratio. That means, if you look at this, that means, what would work is A would be proportional, A to B, and B would also be with C, or you could even say A and C together. Would have a ratio there. So you could use any of those. All right. But what we're going to do here is we're going to take a look at a little example here. Says the measure of the angles are 5 to 12 to 13. Okay. Find the measure of the angles. Okay. Well, what does this mean? Well, I'm going to kind of draw out a little triangle here, I guess. Let's say we've got something like this. And so remember, this is just the proportion of each angle compared to each one. So this is probably not drawn to scale, but let's say if this was 5, whoops. Well, I'll get back to that. I kind of jumped the gun a little bit. I hadn't explained it. 5, 12, and 13. This is 5 here. So you could say, oh, well, if this was 5, that would be 12, this would be 13. But we know something about the measure of angles in a triangle. We know that what? It has to equal 180 degrees. So if this was 5, that's 12 and 13. Well, obviously, that does not add up to 180 degrees. That's, what, 30 degrees. So that's not enough. But remember what we just did back with the TV example? And we had 32 to 18. And we divided them both by 2 to get 16 to 9. Well, if you did that backwards, if you had 16 to 9 and you multiplied them both by 2 to get back to 32 over 18, 32 over 18 is the same as 16 over 9. Okay, remember, this is, I don't know why that's being so picky today. 32 over 18, remember, is equivalent to 16 over 9. So this is the same as this. What did we do? Here we divided by 2. If we went this way, we multiplied by 2. So to keep these in the ratio to each other, I could multiply them all by something, the same thing, and it would still be in the same ratio. So, and this is where I jumped the gun here. What I'm going to do is the thing that I'm going to multiply by is x. So I'm going to call that 5x, 12x, and 13x, right? Okay. So just kind of by way of another little example here, what if I had 1/2, and I multiplied these by, let's say, 3. What do I get? 3 over 6. Is 3/6 the same as 1/2? Yeah, it's the same thing. And so that's all I'm doing here is I'm going to say I'm going to multiply these all by the same thing, and they have to equal what? 180. So what we're going to just say is we've got 5x plus 12x plus 13x has to equal 180, and then we're just going to solve that. So what do we have here? 25x plus another 5 is 30x, and then divide by 30. And so we got x is 60, or 6, sorry. All right, so x is 6, but what did they ask us for? What's the measure of the angles? And so all we have to do is just plug it back in. That means the angle that's 5x would just be 5 times 6, which is 30 degrees. 12x would just be 12 times 6, which is what, 60, 72? And then 13x would just be 13 times 6, which would be 78. And those then should all add up to be 180. Okay? Does that kind of make some sense, hopefully? All right, proportions. Now, proportion, all a proportion is it's just an equation stating that two ratios are equal to each other, okay? So, whoops. So, here's an example of a proportion. Here's a ratio over here, A to B, and we're saying, well, A to B just has to equal C to D. Okay, they have to equal each other. Another way that we can write this, remember how we did it with the two dots here, is we could say A to B equals C to D. Well, the reason why you put this up again here is there's a little method that we use where we can solve a proportion. And you may or may not have heard this before, but they talk about the means and the extremes. The means and the extremes. Well, remember, when you're talking about something that's extreme, it's like way out there, right? Or really excessive. So if you talk about extreme cold, that means it's really, really cold. If you talk about extreme heat, it's really, really hot. So if you think about it written out this way, you go, what's extreme? What's far out? Well, A and D are far out to the side, right? So this is an extreme, and this is an extreme. And then the other thing was the means and the extremes. So the means, remember, mean is like the average. And so the way I kind of remember it, the mean is kind of like the average, which tends to be kind of in the middle. Well, that means these two here, B and C, are the means. Okay, so you've got the means, B and C, and the extremes, A and D, are outside. Why is that important? Here's why. The cross products property, and you may again have seen this in Algebra 1 before, but basically just says if you take the cross products, which is the means, the product, multiplying the means together and the extremes together, those two things will equal each other. So for example, in this case, if I took A times D, it would equal B times C. So you might think of this as cross products, or sometimes people refer to this as the butterfly method because you're taking B times C and A times D. They might do like that. And oh, it's a butterfly. But if you notice here, what happens? 4 times 5 is what? 60. And then 10 times 6 is 60. So you notice here with numbers, you notice that that's true. Like remember before I did 1/2 and 3/6? Well, we could say, well, what if 1/2 does equal 3/6, right? What if we do the cross products here? 2 times 3? Whoops, 2 times 3 is 6. And 1 times 6 is 6. So we've got the two cross products do equal each other, and you know for sure that 1/2 equals 3/6. So yeah, that works. All right, well, here's how we use it then to solve. Wow, that was fun. Let's see how we can solve an equation with this, okay, or a proportion. Well, all we're going to do is just take the cross products. I don't know, this just cracks me up, all this, whatever happened here. My computer is being a little tricky today, and I don't know, it seems like it's jumping around and doing weird things, but hopefully we'll get through this. We're just going to take the cross product. So that means we're going to take and we're going to multiply 6 times y. And so if we take that multiplication of 6 times y, that is supposed to equal the cross product, the other cross product here, which is what? 9 times 18.2. Okay, those two are supposed to equal each other if this is a proportion. And so we're just going to say 9 times 18.2 is 163.8. So 163.8, and then we just do what? Divide by 6. So y equals 163.8 divided by 6, or in other words, 27.3. So y would equal 27.3. And you should find out, how could you check this? If you wanted to check this, just do 6 divided by 18.2, see what number you get, and then do 9 divided by 27.3. You should get the same number. That's how you can check it. Okay? Another example. Getting a little more complicated. Guess what? We just do the same thing. We don't change what we're doing. We just do the cross products. And so I'm going to do this. So 3 times a negative 26. And that should equal this cross product, right? Now, the key thing to keep in mind is this 6 is you're multiplying by that whole thing. So really what's happening is it's like this is in parentheses here. So when you multiply, you have to write 6 times parentheses 4x minus 5. Okay, don't just do 6 times 4 and make it 24. The 6 also has to get multiplied by the negative 5. So this is going to be 3 times negative 26, negative 78. Then we distribute, like I was just saying, so this will be 24x, but it's also going to be minus 30. And now we have that one to solve, and so I'm going to do plus 30. So 24x equals negative 78 plus 30. Looks like it is negative 48. Divide by 24. And so x equals what? A negative 2. Okay? Does it make sense? Key thing here is don't let this throw you off. But the main thing is you got to put a parentheses around that. If you've got more than just one number or a variable, you have to put a parentheses around that whole thing and then multiply the 6 times both of those. Okay. Example 4C. Oh no, look at now what we have. We've got 3x minus 6 and 4x minus 2. Wow, this is getting really complicated. Guess what? Just do the same procedure. Nothing's changed. We just follow the same pattern. We just do this cross product. 2 times 4x minus 2. Again, remember, what do we have to think about? Parentheses around those two, and also parentheses around those. And we're going to take 4 times that parentheses. So those two things should equal each other. So in other words, we have 2 times 4x minus 2, and then that will equal 4 times 3x minus 6. Again, distribute. We just have to do it on both sides. So 8x minus 4. Distribute 12x minus 24. I'm going to go minus 8x and plus 24. And so this is going to give me what? 4x equals 20. Divide by 4. And so x equals 5. Okay? So again, when you're solving a proportion, you just cross multiply, you know, even if there's these binomials here, or even if there was a trinomial, then you just put those in parentheses and distribute the other number. Okay. All right, last one here. A little word problem for us to do. But we're going to use a proportion here. So think about using a proportion, setting up two ratios. And so it said Monique randomly surveyed 30 students, and 18 had a pet of some sort, a dog or a cat. If there are 870 students in her school, predict how many would have a dog or cat. So you're just taking a proportion of her class and then saying, comparing that to what it would take to make the that same ratio in the entire school. So let's set up a ratio just for a class. Well, let's look at pet owners to total students. Okay, well, what would that be? Pet owners would be what, 18, right? So on the top of our fraction, we'd say, well, there are 18 pet owners for what? How many total students? Out of 30. So let's be 18 out of 30. Now what we can do before we finish this up, why don't we simplify this? It'll make our work a little bit later easier. So remember, 18 out of every 30, we can reduce that. Remember how we can reduce a fraction? So you look at this, you can say, what can we divide by there? Well, you might notice, hey, these both will divide by 6. So if you divide by 6 and divide by 6, this would be what? 3 out of 5. If you didn't see 6, you might have noticed that they're both even. And you say, hey, they could both divide by 2. Divided by 2, and then you'll have what? 9 over 15, and then you might see, oh, 9 and 15 can both be divided by 3, and do it again, and you'll get to 3/5. And so that'd be fine. So this is the reduced fraction there, our first ratio. So we're going to say, well, there are 3 out of every 5 people have a pet in her class. So if that's the same through the whole school, we'll say, well, what would that have to equal? Well, remember, what was the top number? The top number was how many pets they had, or how many people had pets, I should say. Do we know that, or is that what we're trying to find? Well, that's what we're trying to find. So that is what we don't know, so we're going to call it X. The 5, or if you go back to the 30, that was the total number of people in her class. What's the total number of people in the school? 870. So you notice here on top, the way that we've set this up, this is on the top are the pet owners, and on the bottom are the total number of people. Okay, so you notice in this proportion, pet owners to people. On this proportion, pet owners to people. Keep it same, the same thing on the top, same thing on the bottom. And so now once we go to solve this, we just cross multiply like we've been doing. So 5x would equal what? 3 times 870. All right, 3 times 870 is 2610. So 5x equals 2610 divided by 5. So 2610 divided by 5 equals 522. So what we would expect is, if the proportion is the same in her class, we'd expect out of a total of 870 kids at the school, we would expect 522 of them would have a dog or a cat for a pet. Okay, so that's how you can set up a little proportion there to solve that. Anyway, that's all we need to talk about today. Appreciate you being here, and this is Mr. Anderson signing off. We'll see you next time. Bye.